So, this class I will discuss that what is negative skin friction and what are the different cases and how we can determine the resistance or the load that we have to subtract from the pile load carrying capacity due to the negative skin friction. So, what is negative skin friction? Then suppose if we have a newly constructed field. So, that field can be cohesive soil, that can be loose cohesionless soil also. And if the pile is constructed before or after the placement of the field, but before the completion of the consolidation of the field soil, then what will happen that that field soil will deform more compared to the pile deformation. So, in terms of relative deformation, that as if actual case the soil deformation is less compared to the pile deformation. So, relative deformation is the pile is moving towards the downward direction. So, frictional resistance is acting towards the upward direction. But if the relative movement of the pile is less than the movement of the soil, then as if the soil will or pile will move in upward direction. Okay. So, the resistance will act in the downward direction. So, that resistance will act in the downward direction. So, that will basically reduce the friction resistance given by the pile, and overall load carrying capacity will be reduced due to this negative skin friction. So, it is negative means actual friction is acting in upward direction for compressive loading, but it is for this portion because of the soil movement is more than the pile movement, then the friction will act in the opposite direction. So, that is why it is called the negative skin friction. So, this is the condition you can say the first or here this is the condition you can say. So, where this is the field, okay? The top soil is the field, LC is the field soil, and then the bottom soil is the actual natural soil. So, this you can see the field soil movement is more compared to the pile. So, the friction will act in the downward direction, but actual in natural soil deposit the friction is acting in the upward direction, which is the normal trend. So, actual if the some portion of the pile friction is acting in the downward direction. So, overall the net friction will reduce. So, that is called a negative friction. So, we have to take care of this negative friction by measuring the amount of negative friction that the soil or the field is generating, so that we can subtract that amount of load from our load carrying capacity of the pile, so that we can safely design this pile foundation. So, there are three cases that I will discuss. So, what are these three cases? The case number 1, that your field is a consolidated cohesive soil and the soil which is resting over a cohesionless soil deposit. So, that means your pile, the lower portion of the soil is cohesionless soil and the field is consolidated cohesive soil. So, that means the field is cohesive, but the natural soil is the cohesionless soil. That is one condition. Another condition, your natural soil is a very soft soil or soft clay, because it is cohesive soil, very soft, and you are applying a fill over that, and that soil is cohesionless soil. So, that means the cohesionless fill is placed over the natural very soft clay. And third condition, that you can place cohesionless or cohesive fill over a stiff soil. Okay. So, this is the 4 conditions or 3 conditions. Now, let me explain that how we can calculate the negative skin friction for these 4 conditions, 3 conditions. So, first conditions, what will happen that when the cohesive fill is placed over a cohesionless soil deposit, the pile is driven before consolidation is complete within the fill layer. Okay. That can be before or after the placement of the fill. So, in that case the fills, the cohesive soil that will consolidate, the consolidation for the fill that will start or it is already been started. So, but it is not finished yet. So, that means that is why the fill material, cohesive soil will move in the downward direction. Okay. And then the movement of that fill is more than the movement of the pile. So, overall this fill will move downward direction as it consolidates. So, in such case how we can determine the load carrying capacity of the pile. So, in that case the load carrying capacity of the pile we can determine. So, that means this is a consolidated soil and then there will be the distribution. Now, you can ask me that this is a clay soil, then why I am drawing such distribution? Because it is under drain condition. So, because your properties are given under drain condition. So, that means all the properties are determined under consolidated drain test, because we know that there are 3 types of triaxial test: UU unconsolidated undrained, CU consolidated drain and CD consolidated CU consolidated undrained and CD consolidated drain. So, all the properties are determined under consolidated drain condition. So, now if the properties are determined under consolidated drain, why it is under consolidated drain condition? Because soil is consolidating and it is draining, water is flowing out and it is consolidating. So, it is under drain condition. So, that is the actual condition, because the soil is moving downwards because of the consolidation. So, that is why you have to consider the drain properties of the clay. And you know that for the triaxial test, if you do it under CD triaxial test, if this is tau and this is sigma n, then your Mohr Coulomb failure profile will pass through the origin if the soil is normally consolidated clay. So, your C dash value will be 0 if it is a CD test. Okay. So, my C dash value will be 0 and there will be only a phi dash value, even if it is a clay. Remember that, because that you should know, because you have done the soil mechanics course. So, for CD test normally consolidated clay, the cohesion value will be 0, there will be only friction values, and if it is a over consolidated clay, then there will be some cohesion value as well as the friction value. But here we assume that our fields is a normally consolidated clay. So, we will get this type of distribution and then we can calculate the friction resistance or the negative skin friction. Suppose this is the q bar, which is equal to gamma into z, and gamma will be the effective gamma and z is at any distance z. So, the skin friction will be 0 to L C, this is gamma dash into z, there will be k we have to multiply, because gamma dash into z is the vertical effective overburden pressure. If we multiply with the k, it will be lateral, then there will be tan delta, okay. There will be tan delta, and that total you have to multiply with the perimeter of this pile at this zone into dz, because dz will be the thickness of this small thickness. Okay. So, that is dz. Okay. So, this way we can calculate. So, that if I take perimeter out, then gamma dash outside, k out, tan delta also out. So, that will give us 0 to L C into z dz. So, we can write this will be half. So, this will be z, half z square. So, half p is the perimeter, then L C square, because z square means L C square. If I put the limit, then gamma dash k and tan delta. So, here is given delta is taken as for this particular case is 0.5 to 0.95, phi is the friction angle of this soil or the field, and k you can take 1 minus sin phi, which is equal to the k 0. Okay. So, this way we can determine the negative skin friction, total negative skin friction, it is in kilonewton, how much amount we can calculate, which is same as the friction resistance calculation for the pile. Okay. So, friction resistance calculation for the pile we have done the same thing, because in that case we have taken this average friction resistance. So, it will be half into gamma dash z, because this is gamma z, half into or gamma z I should write the L C here directly, gamma z gamma L C into the L C, then the k, then the tan delta, then the perimeter, total resistance into the perimeter. So, same thing we will get, that is half your perimeter L C square gamma dash k tan delta. The same thing we are getting by doing the integration. We have these things we have done during the friction resistance calculation. Okay. So, the same thing we can do here also, we will get that. But remember that if there is a soil layer, then directly if there is a say groundwater table is here for example, then directly you cannot use these equation. In such case, this will be the distribution. Okay, remember that. Okay, then this integration, you can also do the integration, but that integration you have to give two limits, one up to the from the top to the water level, then water level to the end of the negative friction zone. Okay. So, and if you want to calculate in this way, then I have already discussed how we can calculate. In such case, the first you take the two parts above the water table and below the water table, and then take the average stress that is acting at the middle of the each segment. Okay. So, this way we can calculate this negative friction amount. And remember that here this first case, the negative friction will be due to the field movement only. The lower cohesionless soil will not give any effect, significant effect on the negative skin friction value. The lower frictionless cohesionless soil, there that will give the upward friction resistance as I have shown, and that upward friction resistance will increase due to the application of this field, because your effective overburden pressure will increase for the cohesionless soil also. So, that will be the only effect for the lower cohesionless soil, but it will not give any negative effect. It will give the positive effect as it was given before the placement of the fill, but once the fill is placement, that fill portion only give the negative skin friction, and the cohesionless soil will give the positive skin friction, and that skin friction will increase due to the placement of the fill as the overburden pressure will increase. Okay, so, next one, the second case, which is very crucial. So, in the second case, that when the cohesionless field is placed over a compressible cohesive soil deposit, that means suppose a very soft clay, because your pile is installed is a very soft clay, where the consolidation is not completed yet, soil is very compressible. Now, you have placed a cohesionless field over there. So, that means, you have placed some surcharge load over a very compressible soil, whose consolidation is still in progress. So, what will happen? So, it will further consolidate. So, consolidation is not completed yet. So, the consolidation will start for the lower soil, and so that means, the most of the positive skin friction, the soil was a pile was given from this soft clay only. But now, if the consolidation start for the soft clay portion, then there will be a movement, downward movement of the soil, of this compressible soil. So, the negative skin friction will generate in the compressible clay. So, the negative skin friction will not be considered for the cohesionless field, that will act as a surcharge on the compressible clay layer. Okay. So, negative skin friction will be generated for the clay layer only. So, the soil deposits move downward direction as it consolidates. So, in this case, some down drag is observed in the field zone, but major down drag occurs in the zone of consolidation. So, as I mentioned, so there will be a downward movement in the field zone, but that is not that significant compared to the down drag that will be observed in the compressible clay layer. So, that will give the most of the negative skin friction. Okay. So, you can see that this is the total pile length. So, here this is this cohesionless soil is acting as a surcharge crew, okay, which is acting on the top of the existing your compressible cohesive soil. And so, that means, if the pile is not, the length of the pile is not large enough, then the most of the pile friction will be negative skin friction, because in this case. So, that is why to counterbalance the negative skin friction, there should be a sufficient length of the pile. So, that there will be some portion or the top portion will be negative skin friction and the bottom portion of the positive skin friction. So, that we can counterbalance this negative skin friction. So, that means, pile length should be sufficiently large, otherwise most of the portion will be the negative skin friction. And if we provide the larger length of the pile, then this negative skin friction will be counterbalanced by the positive skin friction if the length of the pile is large. So, now there will be a neutral point. So, at the neutral point means, above the neutral point there will be negative skin friction and below the neutral point there will be positive skin friction. Okay. So, that way we can determine what would be the length L1 of the neutral point from the top of the compressible layer, and total length of the pile is L, because the field portion we will not consider during the load carrying capacity of the pile, because field portion we will not consider, we will consider only the natural soil where the pile is installed, and the load carrying capacity will be calculated based on that portion length. Okay. So, here the length is that this length. Okay. So, and so now we have to calculate what is the L1 value. So, to calculate the L1 value, so as we have mentioned, this is the field that is acting on this compressible layer. So, the again the this distribution is like this. Again, this is the drain condition, because clay soil under consolidation. So, it is a drain condition. So, the drain condition means there will be C dash will be 0, there will be phi dash only under CD test condition. So, I can calculate that F n will be equal to 0 to L 1, again your this is q bar is the effective overburden pressure, then perimeter, then K, then tan delta into del Z. Okay, that is the Fn. And when you are there is a Fn part, so there is a Fn is acting here. Okay. Then this is the negative skin friction, then there will be a positive skin friction. So, that we are talking about PPF, positive skin friction, and there is a tip resistance PNP, okay, and this is the PA which is acting on the pile. So, this is the P low, PA is acting, this is the Fn negative skin friction, this is the positive skin friction, this is the tip resistance, and tip resistance there is two parts, one is PNP, another is PP. Okay. So, what is PNP, what is PP? That PNP is the tip resistance that this pile is given, and PNP is the tip resistance the pile is given when there will be a negative skin friction. That means, during the negative skin friction also, when the pile will give some tip resistance. So, that is considered as PNP, and PP is the tip resistance, the normal tip resistance that pile is given. So, that means, here that as I mentioned that when there will be a mobilization of the friction resistance, some tip resistance will be there. Okay. So, I have already discussed that during the mobilization of the friction resistance, some tip resistance will be there, and once the tip resistance friction resistance is mobilized, then there will be a tip resistance will start mobilizing. So, that means, this PNP is the tip resistance during the mobilization of the friction resistance, and then PP is the normal tip resistance that is developed after the mobilization of the your friction resistance. So, here I can write that so that means that actual design condition your PA plus Fn that should be less than 2 or equal to PPF plus PNP plus PP. Okay. So, I should write what is the meaning of different term. Okay. So, this is P is the perimeter. So, that I have not written here. So, I should write that P is the perimeter, then K I have given, tan delta I have given, and LC is the length of the field zone. Okay. So, now here Fn, so that means, here the downward forces as Pa and Fn, and upward forces as PNP plus PP plus PNF. PNF is the friction resistance, positive friction resistance. So, this is the load applied, that is the negative skin friction, this is the positive skin friction, this is the tip resistance, and this is the tip resistance, during mobilization of friction resistance. Okay. So, these are the forces. So, ideally these downward load should be less than the upward load, and if we want to apply factor of safety, you can apply factor of safety also. Okay. So, now this is the tip resistance or the downward forces. So, I can write that this is the downward forces. So, corresponding upward forces will be the PPF plus PNP, because during mobilization of the friction resistance, there will be some tip resistance and then the positive friction resistance. So, that means the negative friction resistance should be counterbalanced by the positive friction resistance plus some amount of the tip resistance. Okay. So, that is positive friction resistance, and positive friction resistance will be 0, not 0, because Fn is the negative friction resistance or negative skin friction, So, these terms I have already written. So, it is not required to write, because it will only kill the space. So, these things I can write. So, 0 to L1 is the negative skin friction, and L1 to L, that means L1 to L is the positive skin friction, and the equation is same. Okay. Q bar, P is the perimeter, K tan delta into dz plus P and P. Okay. Now, what is Q bar here? Q bar is the surcharge Q0 bar, which is acting at the top, plus the overburden pressure. Overburden pressure is gamma dash into Z at any depth, Z is at any depth. Okay. So, that is Q bar. Now, for floating pile, we assume that P and P contribution is 0 for the floating pile, but tip pile there will be some contribution. For floating pile, we assume that P and P is equal to 0. Okay. Or we are assuming the contribution is tip due to the friction resistance mobilization is very small. So, we are neglecting that. So, now we can write that, because we have to determine the neutral point at where. So, your some above that will be negative skin friction, below will be positive skin friction. So, we have to equate this downward and upward forces, so which are counterbalancing the skin friction. So, here we have written ppn, that contribution is 0. So, only the positive skin friction will be equal to the negative skin friction. So, that means here we can write that Fn will be equal to ppf, which is positive skin friction. So, if I write that Fn is equal to ppf, so if I take this is outside, Fn is Pk into tan delta outside. So, this will be 0 to L1, and there will be Q0 bar plus gamma z, gamma dash z, that is Q0, because this is the expression, this is Q bar, Pk tan delta you have taken outside, and Q bar is Q0 plus gamma z dash z, that will be equal to Pk tan delta. Now, this is from L1 to L, again P0 bar plus gamma dash z dz. Okay. We are equating that. because basically we are counterbalancing the negative skin friction by the positive skin friction and some the tip resistance during that process, but that tip resistance we have neglected. So, that means we have to make the pile length sufficiently large, so that the developed negative skin friction can be counterbalanced by the positive skin friction. So, if I cancel this both side and then we can integrate this. So, this will be q 0 bar, then z and the z, if I put limit L 1, then plus gamma dash, this will be L 1 square by 2, because it will be z square by 2. Then this will be again q dash and z, that means L minus L 1, then plus gamma dash by 2 L square minus L 1 square, because z square. So, L square minus L 1 square. So, now we can write the L 1 value is equal to L by L 1 L by 2 plus q 0 bar divided by gamma dash minus 2 q 0 bar divided by gamma dash. So, this is the expression of, or this is the expression of L 1. So, L 1, this is the expression of L 1, and that we have to use for our negative skin friction calculation. So, we can determine what is the value of L 1. Now, if I put q 0 is equal to 0, which is practically is not possible, just to get an idea what would be the approximate value of L 1. So, we have taken q 0 bar is equal to 0. The L 1 is roughly coming out to be L by root 2, but actually q 0 will not be 0, okay? Because if the q 0 is 0, then this consolidation will not start. If we do not place any field, then the consolidation will not start. So, that is equal to L is close to L by root 2. Okay. So, in the third case, quickly I am just explaining the third case, then I will finish today's lecture. So, in the third case, the case is when the loose sand, because in previous two cases we have considered that is the field is consolidated soil, but that is a clay. Okay. So, both the cases the reason is due to the consolidation of the clay. In first case, clay is the field and the soil is cohesionless. Second case, clay is the natural soil deposit and we have placed a cohesionless field. But there is a third case where the natural soil deposit is very stiff soil. Above there we have placed a very loose soil. So, but here the natural soil there will be no consolidation effect, because it is a very stiff soil, it is not that much of compressible. So, consolidation will not make any effect for the natural soil, but as the soil is very loose soil, so negative skin friction will develop for the top portion due to that loose soil. That is also another reason. So, in that case, so that will be under undrained condition, okay, because if it is a loose soil, so whether the drain properties you are considering, so that will also, even if you consider the CD test, so loose soil also giving you the phi value, okay, for the sand, CD test also. So, but the unconsolidated plot I am coming later on. So, that means it is giving your phi value. So, that way you can determine the same way that you we did it for the first case, but only difference in the first case was clay, second case, but here it is sand. But here the same way we can determine the value of a negative skin friction for cohesionless soil. But if there is a water table as I mentioned, then you have to modify this equation or this diagram. So, that we can done, but sometimes if the clay soil is placed, so and if the undrained properties are given. So, in few cases you will find actually even for the first case also you should use the drain properties, because that is the actual condition. but sometimes you will find that you have the undrained properties. Okay. And here also you can place the clay fill also over the stiff soil. You can place clay fill also over the stiff soil, but that clay is very soft clay, okay, soft deposit, but that will consolidate. So, here also ideally you should use the drained properties, okay, because that is the consolidated. But if you have the unconsolidated, consolidated or undrained properties are given. Okay. So, in that undrained properties are these, then you have to use this equation, which is the same equation we use to determine the frictional resistance of the clay. Okay. So, this is the equation to determine the but if consider that it is the unconsolidated layer, then only it is possible. But so, this is the special case where the say undrained properties are available, then only you use, otherwise straightforward 3 cases. First case, consolidated clay over cohesionless soil, where you have to use the drain properties, CD properties. Second case, cohesionless fill is placed over the compressible consolidated layer, drain properties. And the third case, where the very loose sand is placed over a stiff soil, okay, or very stiff soil, then you have to use the cohesionless skin friction contribution. But if for the clay is placed over the soil and then there is a undrained properties are available, then you can use these condition. But if the drain properties are not available, then only you can use, but otherwise you should use the drain properties. So, in the next class I will solve one particular problem to show you how you can determine the negative skin friction. Then I will finish this pile part under compressive loading. Thank you.